If you want to understand IPv6, we've got to start at the beginning, and that is dealing with IPv6 addresses. So in this episode, all we're going to be doing is understanding the actual IPv6 address structure, what it looks like, and some tricks we can do to manipulate it. So let's go ahead and get started, and I'm going to go ahead and throw an IPv6 address down right there. Now, if you look at this address, number one, you're going to notice that it's broken up into 8 groups of 4 hexadecimal values, separated by a colon. Now you need to be careful because on the exam they have a couple of really simple questions that'll say things like, which one of these is the valid IPv6 address? And you need to be comfortable, always start with, you're going to have 8 groups separated by 7 columns. So this is a lot of writing. So if you can imagine a world where you are in a static environment and you have to type this stuff in, it would be nice if we had some shortcuts. So I want to show you some of the shortcuts that we use when we're typing in IPv6 addresses. Okay, so first of all, if you look at this address, you'll see that there's a lot of groups that start with zeros. So the first thing we can do whenever we're doing an IPv6 address is we can dump all the leading zeros if there are any. So we get here and the four zeros gets reduced to a single zero. That 0001 we had is now just to a single 1. And this makes it a little bit shorter and a little bit easier to type. So that's one trick. So what I want to do, let's go ahead and get rid of that. And now let's put up another IPv6 address. Now I need you to look at this address very, very carefully. You'll see we have 2 groups of 4 zeros, and then we have 3 groups of 4 zeros. Got the idea? Sorry, yeah. Okay, so what I want us to do is I'm going to show you how we can concatenate this. Whenever you have groups of zeros, first of all, let's go ahead and take all those 4 zeros and just replace with a single 0. All right, now as you look at this, we can take any long string of zeros and simply replace it with a double colon. So let's do that with the first part. So we have FE80 colon colon 1, 2, 3, 4, and then the rest of the address. Now you'd say, well, Mike, why don't we make another double colon for these other zeros? Well, let's do that for a minute. So just for a moment, I'm going to make a bad IPv6 address here. So we're going to have FE80 colon colon 1, 2, 3, 4 colon colon 1, 2, 3, 4. So now we have 2 sets of these colons. I have a question for you. How many sets of zeros go in that column and how many sets of zeros go into this one? And the answer is you can't do it. You can use this double colon nomenclature, but only in one place on the address. So let's go ahead and reset it back to its original setting all the way, all right? And this time what I'm going to do is I'm going to replace the 3 groups of 4 zeros with a double colon. So let's go ahead and make it FE80 colon 0. We can still drop the leading zeros, colon 0, colon 1, 2, 3, 4, colon colon 1, 2, 3, 4. When you're working with IPv6 addresses, these highly concatenated addresses are much more common. Pretty much all IPv6 addresses are going to have long strings of zeros in them, well, at least for the next 100 years, we hope. And it's very common to see these types of addresses where you're always going to have a double colon in there. So be comfortable with that. Okay, so now that we understand the basic structure of an IPv6 address, let's talk about where IPv6 addresses come from. Now the first thing you need to understand, and this is a big one, is that with IPv6 you no longer have a single IP address. You now will have at least 2 IP addresses. One address is called the link local address. The link local address is automatically generated by any IPv6 capable host the moment that device starts up. The other address is called your internet address. The internet address is given to you, at least in part, by your gateway router. So you'll always have at least 2 addresses. Now let's go ahead and see this. So I've got my system up over here and I'm in Windows and I've run ipconfig. Now if you look just at my Ethernet adapter here, first of all you'll see that it says IPv6 address. Do you see that? That's my actual internet address. I have these temporary addresses which I'm going to ignore for the moment. We'll address these in other episodes. But here's the big one. Do you see link local IPv6 address here? The link local IPv6 address always starts with the first four groups being FE80:00:00:0000:0000. And you can see we've just done a double colon there. The next four groups are actually generated by your MAC address. Now I want you to look at one more thing here. Do you see that %14? That is a Microsoft Windows thing, and I want you to just go ahead and ignore that for right now. And instead, let's concentrate on where does your link local address come from. So let's go ahead and draw this up real quick. So we know that a link local address always begins with FE80:00:00:0000:0000. We got that part. So the first half is always the same on all computers in the universe. The second part comes from your MAC address. So let's say on this particular system, we have a MAC address of 2A, 3B, 4F, 09, 4501. Now hopefully you know that a MAC address is only 48 bits. So we use a standard called EUI64 that will take a 48-bit MAC address and turn it into the last half of our link local address. So to do this, we'll split the MAC address in half, and we add FFFE right into the middle of this. Now the next thing we do is we have to, bear with me folks, you see that 2A? So that's the first 8 bits of our MAC address, which is quickly turning into our last half of our link local address. Those first 8 bits, we have to flip the 7th bit. So that A will turn into a 9. Now, before we go any further here, let me stress something to you. It's important for the exam that you know that EUI64 exists. The important thing here is that I don't want to turn this into a big hexadecimal to binary course. I would strongly recommend you check out other episodes in this series that do that, or you can actually check out my A+ course. We do that as well. The bottom line is that A gets turned into an 8 because we flipped the 7th bit. This is only important for understanding EUI. You're not going to be tested on that stuff. Let's go ahead and go back to this diagram and let me show you what's going on. So we've now converted our MAC address into what is about to become the last half of our link local IPv6 address. So at this point, let's go ahead and convert this into a nomenclature that makes more sense. So we'll take our FE80::, and let's just draw all this in. So we're going to have 28, 3B, and let's make a colon, and then 4F, FF, and let's make another colon, and then FE09, and let's make our last colon, and then 4501. So that, folks, is where your link local address comes from. The cool part is link local addresses automatically generate. Now, for those of you who are comfortable with IPv4, you'll go, well, Mike, isn't that kind of like an APIPA address? Yeah, it's kind of like an APIPA address in that your system will generate that automatically. But remember, APIPAs are only generated when you can't find a DHCP server. So I wouldn't call it exactly the same type of thing. But the important thing is that if every computer that's IPv6 capable can make its own link local address automatically, assuming it's plugged in, they can start talking to each other automatically. And that's where things like neighbor discovery protocol come into play. Now, before we dive too deep into that, what I would like to talk about is something that's fascinating. And to do this, let's go ahead and just put up some arbitrary address here, all right? When you look at this address, what is very important to understand is that this is a 128-bit address. Just because we're running IPv6, that doesn't mean that we don't have subnet masks. That doesn't mean that we don't have default gateways. It's just longer. So when we're talking about IPv6, the smallest subnet mask you can have, and remember, let's use proper CIDR format here, is a WAC64. So no, you can't type this into 255s. Everything is CIDR now. So it's always going to be a WAC64. Isn't that interesting? You think about this. That means the smallest network, let's say you only have 2 computers. With IPv6, you're going to have 2 to the 64th power addresses. Crazy, huh? Does that seem wasteful to you? In fact, a lot of people who helped develop the IPv6 standard would agree with you that even if I only have a 2-computer network, my subnet mask is always going to be WAC64, which is gazillions of computers. And people argued about this quite a bit, but that's how it is. So in the IPv6 world, you never type in a subnet mask because the subnet mask is always WAC64. No exception. Now, okay, there is some exception to that, and we do actually have variable length subnet masks, VLSM format, but that's usually for routers up on the internet where they're breaking a subnet down and down through aggregation. They'll be using things like WAC32s and WAC48s and WAC52s and things like that. But that really doesn't trickle down to us individually unless you've got a fairly advanced enterprise system with lots of routers and that type of thing. So when we're dealing with IPv6, what we're really talking about is everything's pretty much automatically handled for you, and we'll do that in actually the next episode after this one. So what I want to do right now, though, is I want to go back onto my system, and I want to show you that there are situations where you may want to actually do some configuration. All right, so here I am in Network and Sharing Center, and what I'm going to do here is I'm going to go directly into the properties for my Ethernet card. Now this should look pretty familiar to us. We've certainly done this other times in other episodes where we were messing with IPv4, but this time let's mess with IPv6. Now if you take a look at this, you'll see obtain an IPv6 address automatically. What it's telling you here is it's saying, listen, the router will tell me what my IPv6 address is. However, if you actually wanted to type it in, you really could type it all in here. And again, notice that the subnet prefix length, they leave this in as an option, which is actually kind of interesting because I just told you that for a network it's always going to be WAC64. There are a lot of people at Microsoft who said, Microsoft, why are you having us type in WAC64 every time? Can't they do it automatically? And Microsoft's answer is we just want to be a little bit flexible. So you're going to type in WAC64 there, but you could type in. And if I wanted to, I could manually type in an IPv6 address. There are some situations where you may type in an IPv6 address. With IPv4, things like servers, for example, would always have a static IP address. With IPv6, it gives us a little bit more flexibility. And if you have a local DNS server, you probably wouldn't even be doing this for a server. Everything pretty much just goes ahead and generates their own stuff and gets their internet address from their router by itself. So it works out really well. One more thing to look at before we leave here, and that is DNS. You still have to deal with DNS. We'll see in other episodes that the router will send out what's known as a router advertisement, which should include DNS information. But if you wanted to use a specific DNS server, just like we do with IPv4, you could type it in right here. Now, the last thing I want to mention is that while this is a revolution, it's also an evolution. IPv6 has been taking a long time to get widely adopted. And because of that, a lot of people, in fact, pretty much all operating systems, support a single host that runs both IPv4 and IPv6 simultaneously. So let's take one more look at my IP config. So you see I've got all this IPv6 goo, but look here, I still have IPv4 information as well. What you're talking about here is called dual stack. Dual stack just means you're running IPv4 and IPv6. It makes for interesting situations. So for example, if you type in www.arbitrarywebhost.com and hit enter, remember DNS has to resolve that IP address. If that web host is running IPv6, it'll give you an IPv6 address. If that web host is running IPv4, it'll give you an IPv4 address, and it can handle it either direction. We're probably going to continue to use IPv4 for, everybody's guessing right now, 5 to 10 more years. But it's not going to be that long where we're going to go from a dual stack to a single stack, and the only IP addressing you're going to have is IPv6.